Okay, so we're gonna take it here from the top. Differential equations. What are they? What are differential equations? Well, but first, before we start talking about that, we're gonna look at just a regular, like a quadratic equation. So if I gave you this quadratic equation and I said one of the answers A, B, and C, one of those are the answers, and you didn't know how to factor or use the quadratic formula. Suppose that you forgot, like that would ever happen. So, what would you do? Maybe, perhaps, if you were a smart young lady, a young gentleman, or gender non-specific, you would plug stuff in. And if you did plug in t equals -5, that would work out because you would get 25 plus -10, yeah, that's 15, and then minus 15, and that equals 0. You would get 0 equals 0. Well, that's the same idea for differential equations. We aren't going to learn how to come up with the answers, like how to come up with the solutions, but we're going to learn how to plug stuff in. That's pretty much the introduction to differential equations right here. So differential equations are equations instead of where numbers are solutions, functions are solutions. So there you go. Differential equations are equations where solutions of are functions, where the solutions are functions instead of numbers. They involve different derivatives and functions. Usually, differential equations model how a rate changes because we're using derivatives. The differential equations are going to involve derivatives and functions. And that's all. That's it. So we are going to have something like this. Example 1. Given the differential equation, look at that. That's the first time we've seen the differential equation. It has a derivative, and it has just like some functions. Ooh, even an x there. So given this differential equation, tell whether y equals 3 divided by x squared plus c, where c is some constant. We don't really know what it is. We don't really care what it is. It's just some constant, some number. Tell whether that is a solution or not. So, just like you might have plugged in things there, we're going to try and plug this in. So I need the parts. I need y prime, so I'll figure out y prime. I need to know what y squared is. I'll figure that out, and then I'll plug it into this and see if I get something that's equal. So just like I said, the first two things they're going to be to find y prime and find y squared. Why am I doing that? Because I need to plug in a y squared and I need to plug in a y prime. It's very, very simple. And then I'll multiply the y squared by an x. Okay? Okay? Okay! Now to find y prime, I just use the product rule. And I get the low d high minus high d low all over low squared. And then I simplify that. So that's this part. It's just simplified. So I got y prime. I'm ready to plug it in somewhere. And then I'm also going to get a y squared. So I just take y and I square it. And that's easy enough. Y is this. So the top squared is 9. And the bottom squared is the bottom squared. Yeah, so there we go. I found the pieces. Now I need to find the rest of it. So hopefully this doesn't screw up my video, but I'm going to stop this. So now that I got my pieces, I'm going to plug into my differential equation. My differential equation is y prime equals all that stuff. So I'm literally taking y prime, I'm going to put it there. I'm going to take a y squared and I'm going to put it there and with the x in front of it. I'm just literally taking this piece, putting it there, this piece, putting it there, and then I have that x there. So I'm plugging it in. This is me plugging it in to the actual equation. And then I'll simplify a little bit. And then I realized they're not the same. They are not the same. Look at that. They are not the same. Look, we got a -6x. The bottom is the same. That's nice. That's quite nice. The bottom's the same, but I need everything to be the same because I say this equals means the same. So -6x and 9x, those are not the same. So no, it is not a solution. They're not equal. So let's go back to our question. What did it say? Given this, tell whether it is a solution or not. It is not a solution. It's not a solution because it does not equal. It's not equal. So there you go. That's what you get. That's what you get there. I do know, however, I do know the solution. Although in this section we're not going to be able to come up with solutions. We'll learn those techniques a little bit later. We are going to check a different thing because something that is a solution, just so you can see what it looks like. So I'm going to have a different question with the same, I guess it's the same differential equation. So let's use the same differential equation, and we're going to have this is y equals -2 over x squared plus c. Is that a solution to the same differential equation? I'm still looking at the same differential equation. So is that a solution? Well, I got to do the same things. I got to find y and y prime. So that's what I'm doing there. Y prime, because remember, I still got to plug it in. I got to have y prime, and I got to have y squared and y prime. So I do that, and then I plug it in. So plug in that. Again, I'm plugging it into this. I have y prime equals x times y squared. Ooh. And then I'll simplify a little bit. And I do see, so if I take these and I simplify 2 times 2x is 4x. X times 4 is 4x. So now the tops are the same. So yes, this, what our new question, right, that is a solution. So we can say yes. So that's the exam of example 1, the end of example 1. Yeah, so we get a differential equation, and we plug stuff in and see if our solutions are actually solutions. That's it. Goodbye.